Alrighty. So, I guess let's get rolling here. Hopefully you all know me from the last keynote. Yes, it is me, no suit this time. Yeah, if I do a keynote next year, that may be the next time you see me in a suit. I did that for OSCON, and that was the only reason I wanted to keep the whole momentum thing rolling. All right, we're going to talk about what is currently proprietary, but is going to be on CPAN once we get a few bugs worked out in the system module. I have been told by members of the DBIc Inside Circle that I should not be using the name DBIx LazyCache for this. Instead, DBIx class LazyCache. But that's just because that was shortened for the talk. I will change that before we do a final release and put into the proper namespace.
So it will be named instead of DBIx classes?
Something like that, yeah. We have DBIx experts here. I will ask them about the appropriate nomenclature for that. But I assure you right now that it is actually all based on one helper file. So it's one simple small file that you can dump in your system. Okay, I'm here with Clearbuilt, and at least two of our staff are Mike over here and Ruth back there. Party on. Yeah. In case you want some links, there's a place to go. Wait a minute, did I put? No, I didn't put up my site on there. Okay, no problem. This talk will be up on GitHub. It is up there right now, running on GitHub, and I'm not quite yet running it off GitHub, but it will be on there after the talk, sometime this afternoon or tomorrow, depending upon how much time I have after the conference. Tee. All right, we're going to talk here about an extension that I came up with as part of a fairly long-running project, I will admit, to do another layer, yet another layer on top of DBIx class. This one provides a little better caching for entries. It will do lazy evaluation of certain things if you want to. It will also do cache invalidation. And it will also basically create a way to integrate your business logic into one file, or at least into your schema. We're right now working with Dancer as our main application. We had some configuration that was tied to Dancer, but we got rid of that as part of the project. Hence why we work with Dancer. But it does integrate with Dancer, integrates with pretty much any DBIx module that you have. I'll show you some examples of that later. But you're probably wondering what this is good for. So you're probably wondering what this is good for. First thing, you get a little bit more fine-grained control over your resources, specifically who can actually access your columns and rows. I did some research and found out that at least some SQL support removing select and update from, removing grants from individual columns. Some SQL support, some do not. We also give you one thing that is currently missing in most SQLs, which is calculated columns. Postgres will have it in the new version. Oracle has it, and a few others have it. It'll be part of the newer. It is part of the new SQL standard, but that's not. The vendors have not yet caught up with it. So that standard is out there, but we give that to you for free. And we give it to you in Perl, which is another benefit. Last thing is, cache invalidation is sort of a misnomer as far as I'm concerned, but I'll call it that for the sake of the talk. What we really do in the background is let you basically create and destroy entries in your current namespace. So you probably want to see. A lot of this in action. Hopefully. So let's jump in brief. So let's see here. Cache invalidation. The cache invalidation really is more of dependencies on columns. If you have, for instance, in business logic, if you have, say, for this purpose, you have a set of projects that you're working with in your database. Those projects are all composed of items. The items have an ID, obviously a name, and a parent project ID. This is by no means the correct way to do database work, but the fact is that we all know how legacy data is. What we have is kind of better suited to a data warehousing situation where you want to record static columns continually instead of a live situation where you're doing more updates. And it is also not one of the things that we do right now is we use nulls to signal the cache invalidation, which is as they say nowadays, not a good look. But what I'm going to do is make sure that is subclassable, so that you can do your own work on that. One technique that Joe Chelko recommends, a database guru that I advise to look up, funny last name, Celko. He advises that instead of using nulls for this sort of work, that you have a separate coordination column in your database. So this is a sample set of tiny schema that we're going to work with. And there is some business logic here that we can talk about. We'll put some constraints on. The first thing is that we want all of our IDs to be read-only. You don't want to go in there and tamper with that. So from the DBIx layer, you don't want to be able to, say, update rows. You don't want to be able to update that column. In fact, you want it to throw an exception when someone tries to mess with that. The project's price is equal to the total number of items. The total price of all of its items. So you don't want to maintain that. You want to have something else do that work for you. So this is a little bit of business logic in your code. If you were working with this in more of a standard DBIx or Dancer or any MVC application, you will probably have some code scattered in several points wherever you do an update or update on the items or an insert to your items table and keep the project column up to date. Which again is sort of bad database design that is barely third normal form, and you want to at least ideally keep your database in full normalized form. But again, this is more for a legacy situation. You want to be able to, your item's total price here is the quantity times its unit price. And whenever, say, you change the unit price, you want to be able to change the total price automatically and have that work in the background. When you change the quantity, you want the total price to update. So these are all of the business logic rules that we'll encapsulate in this. So, let's say a quick poll here. How many of you folks write quote raw unquote DBIx schemas? Anyone? Okay, a few out there. All right. So everyone else uses a schema loader. Okay, a few people. And how many of you use DBIx Candy? Okay, and at least 1 or 2. Cool. Luckily, we do all 3. We will support you. We will support this for raw DBIx. If you want to use schema loader, we can do that. If you want to use Candy, we can do that as well. So you're probably familiar then with a line like this. you want to add columns to your database. And as I said before, you want to make sure that all of your ID columns are all read-only. Wouldn't it be nice if you could just add that to your spec? Just say read-only right there in the description. That's what we support. Add, ooh, that line goes off the edge. Oh, just barely. All you have to do is add the new DBIx helper component, and you can add in is read-only.
How do you do that with schema loader?
Glad you asked. You are quite correct, but what you can do is afterwards, you can use a helper. You can use the helper method, because one of the things that DBIx lets you do is export commands inside the helper. So what we do also is create a helper like so, way down here at the bottom. Questions over there, or okay? So if you want, so we support writing raw DBIx. We support writing with schema loader. That was especially important in our case because we also have a long-term plan to generate all of this from a separate YAML file, or at least I do. I don't know if we'll talk about that later on. Whoa, that was not good. There we go. Laptop HDMI starting to flake out on me. That's not good. So anyway, we support this through afterwards. The important thing for those of you that don't use schema loader is what schema loader does is it creates a file and then generates an MD5 hash of the content so that the schema loader tool knows when it's been modified. So what we do is provide both a way that you can insert this into the schema block directly, like so, or you can modify that after the MD5 hash has been created. And this works as, again, a helper method that you export from within DBIx helper. And finally, for the one person out there that actually knows of and uses DBIx Candy, which I was very lucky to be able to read through in the documentation, because even I didn't know it existed. You can also use a more DSL style. This just gets rid of the package declaration and it looks back like a regular pre-schema loader situation. So you have just the load components without the package arrow namespace, and that's about it. You can add as many, for the make read-only, you can add as many names as you want. So you use make read-only QW of ID, space name, space price, etc. So going a little bit deeper here. Let's see here. So this is so after you add one of these to your setup, the next time that you try to load a result set and try to modify that column, you will get an error. This, to be fair, it is croak rather than die, so this way you can cache that inside your modules. So it is a exception that you can rethrow or cache as you so wish. That way you don't have to have warnings potentially leaking out back to the user or into your error logs where it might show inappropriate information. Again, for those of you that don't read DBIx that well, and there may be a few out there, we're creating a result set. We're creating a set of rows from the item table, finding row 1 of that, and trying to modify the ID, which we have declared back here at the bottom line there to be read-only. So now when you go through and try to update, that column, it's now read-only. Effectively read-only, as long as you use the DBIx layer. If you go down to DBI, of course you can yes.
What do you call updates? The update method ID
It's actually the same thing. It has the same effect. What we do is we basically patch the set column and get column methods inside there.
What do you call update on the result set?
Update on the result set object. That is a good question, and I don't offhand.
Unfortunately, I'm just telling you, you have to implement that completely separately. So if you haven't handled that case specifically, it will go through.
Okay, we've actually done that. Well, not that way. We did this as the first pass to work on this. When this was originally a set of moose classes and subclasses. So I've done that before to patch the result set call, but I will certainly add that as a test case, definitely. We did that beforehand as a moose subclass that overrode update and a lot of other methods, and that got very, very ugly. But I will hope and assume that is the same as creating a helper for the result set rather than the row. And I take a look at that. Good thing we have people here more knowledgeable than I am about such matters. Always helpful. Thank you. Okay, so that is how you protect a column. Again, some databases support that natively, some do not. What we're trying to do here is develop a platform neutral layer, so you can add that to any database support. Say SQLite, which I don't believe does that, and a few other databases that don't support column level updates. And this way you can customize the error message instead of having a obscure message like, say any of Oracle's errors coming back with an 00123445 error, which you have to look up each time. So the next thing that we want to be able to do as part of our business logic is whenever anyone goes in and updates the quantity of an item, we want to be able to update total price transparently and on the fly. And you can actually do this. I'm still working on one problem, but you will be able to do this in a lazy fashion, hence the lazy portion of LazyCache in the name. So let's break this down, see what's going on, how to do this. Okay, let's see here. What do I have? All right, so the first portion of this is cache validation. So when someone goes in and tries to alter a column, what we want to do is be able to clear the dependent column. Pardon me. So in this case, you can add the invalidates attribute to a column. So basically what happens in this case, when quantity of an item changes, we remove the total price and we follow up the DBIx chain to remove the project's total price, because that's now invalid as well. Because again, a project is comprised of multiple items. We do not yet support many-to-many. Right now it is one-to-many relationships that we support in this fashion, one-to-one, one-to-many. So if you have an item that is in multiple projects, right now we don't support updating all of those project IDs, which probably is a good idea anyway. I start out a little bit leery of the whole action at distance aspect of this, but I'm warm to it. So we chose, one of the quirks here was that we chose to use the arrow notation here for project arrow total price rather than project.total price, because project.total price would imply that we're doing a DBI update. This is all done using DBIx code internally, so there's no magic going on to call directly out to the database to update those entries. if you know how DBIx works internally, that is awkward because DBIx itself has a caching layer, which we used. What this does is when you do any sort of changes to the quantity, we quote invalidate, unquote, by setting to null that value. Now, what I should also say here is, again, if you're using regular DBIx class, we also offer the invalidates method, so you can run that directly anywhere in your schema. What that does is it simply adds alongside the data type and the name of the column, it adds in the invalidates listing. And this again will take any number of arguments. So you can give invalidation, so you can give each column in your database some sort of invalidation. Right now I don't support just a single name inside the brackets. You need, a single column name without the brackets. That's the one catch. But I figured that most of the time, and Ruth might be able to attest this, most of the time, you want to use multiple names anyway in this, because we have some tables where one change to an item will update effectively 7 or 8 columns. Will effectively update 7 or 8 columns in the database. And again, this is the sort of work in Dancer or Modulicious or Catalyst that you will likely have scattered around at several points. Whenever you have an edit page for an item or an edit page for a project, you would need to do the sort of work at multiple points in there. So what we do here is, instead of having to go through subclassing and updating text, what we do there is, again, unify your business logic into one file. And of course, it also works in DBIx Candy because we have the same accessor. So you can call invalidates directly without any intervening steps. So now what happens? So now what will happen when you update your unit price and your quantity, say, as one statement? What will happen there? First of all, we will assume that right now the total price is set to $20 or something. So what happens after this step? Ordinarily, nothing special would happen in DBIx. But what happens now is when this statement runs, you find out that you're updating. We find out that you're updating the unit price. So you have changed the total price of the item. You're updating the quantity, so you have changed the total price of the item. So right now what happens is it will simply return, it will null out that field. So you get back 0 for your item total price, which is probably, as I say, not a good look. Because what you really want to do is have that recalculate things. We have separated these two steps out deliberately, because what this lets us do is lets you do lazy evaluation of this if you wish, because you don't have to update, because this way you can update the unit price and the next and have that be separate from recomputing the total price. We separate those two steps into stages. So instead of resetting total price, what we do is the first step is you invalidate the total price by nulling it. And then what happens later on is you can use your business logic to recompute the data afterwards. So you don't have to do that at runtime. For instance, say you have a project with upwards of 2,000 items. you want to go in and change the unit price of every item and add 2 cents to it because of manufacturer change. You don't want that to invalidate the project each time it goes through and recompute the project price each time it goes through. That's silly and redundant. So what we do is let you simply set to null, and then each time set that back to null, and later on when you actually want the total price, because you may not need it right now. You may be doing bulk updates and not care about the total price of anything. You may not care about projects. It may just be a cron job running somewhere updating prices. This way we separate that, and later on when you actually want to view the total price, you can recalculate that. So that's what this statement here does. So we have here the total price of our column. We have the column total price, I should say. It invalidates the unit price and project's total price. And when you want to recompute that information, it calls down here to the calculation block you'll see at the bottom. So that's what it runs afterwards. So now when it will do the invalidation first, and if you have a lazy flag add to this, which we don't yet have implemented, it will wait until you access the total price to do the computation. So this way you have essentially your logic, your actual computation logic, the cache validation logic, i.e. what happens when you update total price, what does that change? What happens when you update, say, a unit price, what does that change in your database? It's all here in one file. And at the very end you have the calculation to do the total price also wrapped up in that same file at that point. So you've taken your business logic and compressed that now down into one schema file, instead of having to go around to find your update file. Question back there?
Yes.
Okay.
If I see there that invalidates unit price,
Okay.
price is depending on unit price and quantity rather than the other way around.
You are quite correct. Thank you. Yeah.
It's not supposed to work that way.
Right. It's right. So that made me why I got a few confused there. Thank you very much for pointing that out. The bug here that Taylor was mentioning is that, in fact, total price and unit price should be reversed, which is a bug that I wrote in. I actually wrote these the week before. I actually wrote these several weeks ago. Oddly enough, given my style of presentation, that's odd. So that's a bug that I made a few weeks ago and never got a chance to revisit, I suppose. Okay, one more.
Okay, so when is the, maybe you said, but I missed it, when is this calculation run?
Okay, right. Question was, when does the calculation run? Right now, with this configuration, it will run directly after any change to. It will run after any change to the unit price or quantity. So that way you keep the database. That way you keep the database. You keep the rows intact. So you update one thing, and right now doing the nulling is just a signal for later use. You don't necessarily have it. Doesn't necessarily need to do that right now. It will run that calculation right now as it stands immediately afterwards, so that whenever you update one field, the other column will update then and there to keep your data intact.
I'm sorry, but it seems like you said two different things the way I understood it. Like, we just null it, we separated
Okay.
And at this time, it'll immediately recalculate. If you added the lazy flag, which is still being implemented, then it will defer that calculation until you get the accessor.
Right.
And, so then you can either set a cron job to just spin through all your database records and hit all the accessors to update the database, or you can wait until it's requested from a web page to pull it. And it will calculate, so it'll defer.
Right. Hence the first part of the name, lazy. This way, by separating those two aspects, you can either do this on demand and do the calculation at runtime, or you can defer the calculation until you actually need the data.
But it's not lazy by default.
Not lazy by default, no. I figured that having too much magic in this would be a bad thing for people trying to use the system. So it's not there by default.
As a user of this application, I am using this extensively in work I'm doing right now for Clearville. And the beauty of this thing, and lazy isn't implemented yet, and in fact in my use, I don't want laziness. But one change affects a whole mess of fields, which cascade into more fields in other tables, and there's this cascade of calculations of a manufacturing workflow. This affects that, affects that, affects that, affects this, and on down you go. And having all of that centralized in the schema, and there's only one thing that's ever going to calculate this sum quantity or whatever this is absolutely invaluable. Now, in a little later on, one of the things that we're concerned about is in an order, for instance, we order a bunch of stuff. And when we receive, we need to update how much we have on the shelves. And right now, I'm doing that retail. I'm doing it one at a time, and it's updating immediately. But if we're ingesting a batch from a CSV file from a receiving system, some automated receiving thing, we may not want to do that. We want to make it lazy, and then at the end of that, fire off a forked job or a cron or some detached process to run through and look for all the nulls and update them. And so we're looking at how to balance that. You may, there may be cases where you want pure laziness, don't update until you access it. And there are times where you want to say, let's just cascade all these calculations and take care of them, but do it now. And balancing that is going to be, there's a little bit of treachery going to be involved in that, because probably what we'll do is we'll make them lazy and then recalculate instead of invalidate. There are times we need to do it now, just hit recalculate.
Right, and one thing that Ruth points out, which I don't point out in my slides, unfortunately, because I wanted to create a very simple test case, is that updates in one table can trigger updates in other tables. For instance, in our example here, what happens is if you update a price in the item, it will update the project. You can eventually propagate that backwards if you want. It eventually propagate if you say, if you have, say, a markup value in a project, which all of the items have that markup applied, then you should be able to validate that markup, and it will validate the table, the item table entries down there as well. That is one way to do things. You can cascade these. And what I intend to do and have done already, but is not yet in development, is not yet ready for prime time, is create a variant of schema loader that is a model loader. So you have your data model, and what it will do is it will take a YAML file like the current schema loader does, and it will apply the runtime attributes, such as it will add a read-only attribute to your tables. It will add calculations as you want from ranges of the code. It will do all the invalidations and figure out the change for you and make sure that you have no loops in your tree. because you don't want to be in a situation where you have table A modify a column in table B, and that triggering an update that modifies something back in table A. So that's one thing that you don't want to do. There's already internal checks for that at runtime, so it's a little bit slow. Question?
But this is all happening inside this particular Perl process's memory. It's not affecting any other instance on another machine that's also processing the same application and the same data. And so they won't know that this update has occurred.
Oh, no, they will.
Through the database.
This is not done inside DBIx. It is done by actual database updates. So when you do an update on one field, it will go through and actually write the update record back to the database.
You're actually storing the data.
Correct.
So unlike Oracle's calculated content right in there.
Right. There are a few databases, as you point out, that do right now do calculated columns. You can also think of this as well as, say, a view that you can actually do updates on. If you will. Teo, back there, what's up?
Because now I'm getting a little confused.
Oh boy.
If I would set the price of the item, it would invalidate the total price of this item.
The total price, if you change, as it is, if you update the unit price of an item, yes, it will change the total price, because if you have,
I'm trying to be very careful with choosing my words. If I set the price, the DBIx class object itself will have a new price. It will be invalidated by LazyCaching, but I haven't done an update yet, and the update will trigger the database transaction. Am I correct?
correct.
And only at that time, the rest of the database, like he's saying, will be notified of changes in the total price.
What happens internally? Just to clarify, he was asking about about the actual nuts and bolts of what happens during the when you actually perform an invalidation. I'll walk through that again. What happens when you update the unit price on an item? We want to assert the business logic to make sure that the total price of that item is always going to be the unit price times the quantity. So what we do then is, at that point, we do an actual database update of the value at that point. Yes, that right there is what gave me pause when I was first asked to think about this, because action analysis can be a scary thing. So I am 100% with you on how this may seem to be a bit of deep magic.
So if I do multiple setters on different fields, different columns, or you want to call them attributes, on this one item, if it would have multiple columns, it would go back and forth to the database for every time I set one of the columns.
You know, I'm glad you mentioned that. For instance, in, say, a situation like this, if you want to update a bunch of items in bulk, as you're talking about, or even update one item that has a whole bunch of columns in it.
And I do it sequentially, not in one column.
Right. There are ways to do updates to result sets in bulk. That's what Henry was alluding to earlier, and that will be a separate helper eventually. Right now, it is just a helper for an individual database row. I haven't yet gone around to helpers for the whole result set. We're still working on refining this model. But to answer your question, in this case, you have a whole you are going through and updating columns in bulk. And you might want to, and so what we offer here is a way to suspend the recalculation step. Those of you that are familiar with DBIx transactions may recognize the paradigm here. You access the handle, you access your item, and tell it to suspend calculation in the database temporarily. So while this is in effect, no recalculation gets done. There's no changes made, so it will not do multiple updates. Yeah. So it will do that, and if you want, and also if you need to bypass say the read-only attribute on column, we have ways to suspend that as well. If you need to bypass invalidation, we have ways to do that as well. And this right here acts as a stack. So you can have multiple with and you can have multiple without calculation calls nested inside each other. Or you can also have item with calculation to unsuspend that temporarily inside. We already thought about that possibility, and it is all internally stack based. So when a calculation gets run depends upon where you are inside a nested level or none of the subroutines here. So you can suspend, defer that, or better yet, in that case, a better option would be to set is lazy on that flag, on that column, if you have that sort of work to do, because then it will take. Because then what it will do is not do any calculations until the moment that you fire off an accessor or you read a column. So this way you can get rid of some of the magic of that, and also instead of having to go into your database and do a change of grants, or go to 3 or 4 places in code and change a calculation, or temporarily suspend a calculation in 3 or 4 places, or temporarily go in and make a column null. This way you have one place in your code directly in your schema file where you make the one change. And again, this will operate for all calculations inside that, regardless of what table they're working with. So this will suspend calculation across all of the DBIx classes temporarily. There are ways as well, if you want to be fancier about that. You can also pass in a column name to say do not calculate this column, but do all the others. If you add the calculation name you add the column name just before a subroutine, it will say suspend only calculation for that column. So you narrow down the limit of magic on that. So yes, we thought about that pretty much from the beginning, and had a lot of talks about concerns for how much magic is going on here. Getting to the end of things here, so do we have more questions? I'll show you the last bit here. So for the file summary, you can add is read-only to your columns. You can add invalidates, which says I'm going to drop cache for this column. I'm going to dump the cache. And afterwards, you can add a calculation field. So that's pretty much a summary. Thank you very much.